Unit 5.3 Solve polynomial equations. The class objective is to solve polynomial equations by factoring and to solve polynomial equations by graphing. So we are talking about two skills here to solve polynomial equations. So the first thing is factoring. The next skill is by graphing. Remember, when we use factoring to solve a polynomial equations, we are basically making use of the zero product properties. So what exactly is zero product property? It means if A times B times C equals 0, then A is going to be equal to 0, or B is going to be 0, or C is going to be equal to 0. So if you change the variable A to an algebraic expression, for example, if I have x minus 4 times x minus 5 times x minus 6 equal to 0, then by making use of the zero product property, that means x minus 4 equal to 0, or x minus 5 equal to 0, or x minus 6 equal to 0. The next skill we're going to learn to solve polynomial equations is by graphing. In graphing, we look for intersections of the graph as the solutions for the equations. If you still remember, when we talk about a linear system of two linear functions, the solutions is always the what? The intersection point of the two linear functions. Same thing applies to polynomial equations. If you have a system of two polynomial functions, say this is the y equal to x cubed plus say 1, and you have another one, say y equal to x squared. So the solution is the intersection point for this system of these two polynomial functions. Now let's look into more details of how to solve polynomial equations by factoring. So here's the problem. Before you solve it, please make sure you read the questions carefully, because they are asking you to find two things: the real solutions, which are real numbers, or imaginary solutions. So when you solve a polynomial equations, you may have the chance to come up with some imaginary solutions like I plus 1. So be careful. In this problem, you have a cubic equations because the power number 3 right here. So the first step is to rewrite the whole thing in p of x. P stands for the polynomial function, equal to 0. The reason we say equal to 0 is because we try to make use of the zero product property later. So all you need to do is minus 3x right here, and then minus 3x. That's why you got this. After we set the polynomial functions equal to 0, the next step is to factor out the greatest common factor. GCF stands for greatest common factor. So in this case, the greatest common factors for all these three terms are x. The reason we do that is because we want to change this factor into quadratic functions. When I say quadratic function, it's because of the powers equal to 2. The reason that we have to always change it to a quadratic function is because we can make use of all the factoring techniques that we learned from our quadratic equation chapter. Let's factor 2x squared minus 5x minus 3. If you still remember the factoring technique that we learned from the quadratic function chapter, you know, since the coefficient of the leading term is 2, is not 1, so we have to use the A times C technique. So in other words, in this case, A is equal to 2, C is negative 3 times negative 3, so we get negative 6. So we have to use the sum of the factors. In this case, we're going to use 1 and negative 6, because you end up getting negative 5 right here. So we're going to write it like this: 2x squared plus x minus 6x minus 3. So we try to find the greatest common factor for these two terms, which is x. So you have 2x plus 1. And then we have minus, watch out, when I do the parentheses, you're going to have minus 6x plus 3. Then we can find the greatest common factor for this factor, which is 3. So here's the next step. So we're going to have x times 2x plus 1 minus 3 2x plus 1. Now we got a common factor here, and then we can factor this out. Do the reverse distributive property. We have 2x plus 1 times x minus 3, which you have right here. So after we do the factoring, we have three factors. The first factor, the second factor here, and the third factors of the polynomial functions. So by using the zero product property, we can set each factor equal to 0, and then we solve for x. And these are the solutions. Now let's take a look at another example. In this example, we're going to combine the factoring in quadratic formula to solve the polynomial equations. So here's what we have. So the first step we're going to do is we try to set the right hand side equal to 0 so that later on we can use the zero product property. So what we need to do is just minus 6x cubed on the right side and do the same thing on the left hand side. Now we have this. Once we have this, because of the numbers are so big, like 3, 6, 12, but we can simplify it. In here they said by multiplying by 1/3, or you can actually divide the whole thing by 3. Divide the whole thing by 3. So right here, 0 divided by 3, you got 0. So we simplify the whole thing into x to the 4th power minus 2x cubed plus 4x squared. Because when you divide by 3, here's going to be 1, 6 divided by 3 is 2, 12 divided by 3 is 4. Once we have that, then we have to use the greatest common factor, x squared in this case, to factor out the whole thing. Right now we have x squared times the whole thing right here, x squared minus 2x plus 4 equals 0. And now we have two factors, these factors, and this whole thing is another factor. So we're going to set these things, set x squared equal to 0, or this quadratic function equal to 0. And then if we can use sum of factor and other techniques to solve for this, to factor this, we should do that. But if not, we can just simply apply the quadratic formula which we learned before to solve for x. In this case, you end up getting an imaginary solution. Let me move this for you so you can see it. So this is an imaginary solution, and this is another imaginary solutions. So of course from x squared equal to 0, we got a solution of 0 as well. So these three, 0, 1 plus I times square root 3, and 1 minus I square root 3 are the three solutions for this polynomial equation. Other than factoring, we can use grouping, sum of differences of cubes, or greatest common factor to solve a polynomial equation. Let's take a look at each of these. So first is factoring by grouping. Let me get a pencil first. So how do you do grouping? You got to have a really strong number sense in order to do grouping. So how do you get a good strong sense of number? You have to practice a lot. So in this case, when I look at this polynomial function, I know right away I can group these two algebraic expressions together. But watch out, because this is a negative sign here, after you put the parentheses, this one's going to be equal to 3x plus 6. For this one, I know the greatest common factor is x squared. So I factor x squared out, so I have x plus 2. And for this one, 3x plus 6, I know the greatest common factor is 3, so I got 3x plus 2. But be really careful, the sign here is negative. So right now I have x plus 2 as a common factor for these two algebraic expressions. So I factor this out by doing the reverse distribution. So I got x plus 2 times x squared minus 3. Once we got that, we set that to equal to 0. We can make use of the zero product property. Then we can solve for x. For sum or difference of cubes, basically we just apply the formula right here. So when this is a cubed plus b cubed, just remember this is a minus sign here and this is a plus sign here. For a cubed minus b cubed, we get minus and then we have plus. Okay. But I always say they probably won't give you a good numbers, just like a cubed plus b cubed. So in this case, when you look at this, it looks like a little bit different from the formula, but if you change it to 2 to the third power, which is equal to 8, x cubed plus 1, you can actually change it back to 2x whole cube plus 1 cube, because 1 cube is equal to 1. Now we can apply the formula. Look, now a is 2x. Okay, let me write it here just in case you don't know. A is 2x, b in this case 1. So a 2x plus b, a squared. So if you say a squared, which is 2x whole squared, that means 2 squared x squared. We simplify that, that's 4x squared. So we got 4x squared right here. So 4x squared right here, which is a squared. So a times b, a is 2x, b is 1, so 2x times 1 is still 2x. b is 1, 1 squared is 1. So after we got this one, we can now, because it's a quadratic function, we can make use of the quadratic formula to solve for x. The last strategy is to factor out the greatest common factor. So let me get my pencil. So basically, there's a general rule of thumb. When you solve a polynomial function like this, and if you want to solve it, we try to make this one to become a factor times a quadratic function, and then we set it to equal to 0, then we can solve it. So in this case, you can tell 15, 20, 35, the greatest common factor for these three terms is 5. And then when you look at the variable right here, the greatest common factor for these three variables are x squared. So we extract this out, or we factor this out, we end up getting this. The reason we do this is because once this one become a quadratic function, we can use different kinds of factoring skills that we learned in the quadratic function chapter to solve for it. And for this one, because we say equal to 0, this 5x squared is going to be equal to 0, which means x equal to 0. Then we can solve this polynomial equation. The last tool that you can use to solve a polynomial equation is actually using your graphing calculator. It is the easier way to solve a polynomial equations, but I don't encourage you to do that unless you know how to solve it manually. Also, the graphing calculator can only show you the real words. In other words, if the polynomial equation do have the imaginary solutions, you cannot see it from your graphing calculator. Now here's the example. They ask you to solve these polynomial equations. When they're written in this way, they basically ask you to solve a system like this. So y equal to, or p of x equal to x cubed plus 5, and p of x equal to 4x squared plus 6. Based on these two equations, we can use the intersect feature from your calculator to solve it by entering these two graphs right here. So this one is gonna be, and for it correctly, but this one is gonna be the x cubed y equal to x cubed plus 5, Well, this one is the function y equal to 4x squared plus x, and we trying to look for intersection right here and the intersection right there. This one is this part actually is the enlargement of this part. So the following clip, I'm going to show it to you in more details. So first, enter the polynomial equations into the calculator, then press graph. If it didn't turn out the way it should be, it's because you didn't set up the window properly. So to set up the window by doing the zoom button, check 6. There you go. So you get two graphs here. The first intersection is easily seen, so we just use shift calculate and then use the intersection function. Look at the things blinking. They're asking you which one is the first graph, so we check yes, that's the first graph we're going to pick. Then we're going to move to the second curve, click yes. So we guess that's the first intersection that we find here. The second and the third intersection is really difficult to see, so we have to enlarge the scale of the graphs so we can see it. So we have to change the window setting. So let's change the minimum x min to -1, and the max is say 4, and then the scale we stick with 1. The mean for y, because we know it's only start from 0, so we change it to 0. And the max, we can say 80, right? And the scale, in order to see it from the window, we set it to 10. Now we graph it. Now you can see it clearly that there are two intersections. Now we are going to use the same intersect function by checking 5. Then they ask you the first graph. Look at the things blinking. So this is our first. We shift back, we're going back a little bit. Well, it's hard to see here, but we're going back a little bit to say this is first graph. Look at the top of the screen. They tell you which graph is which. Then they ask you the second graph is this 4x squared plus 6. We say yes, and then we guess. Now we got an intersection, x equal to 1.1629 something. And then now we move up to find out our last intersection. We use the same function, intersect, and then we just move the blinking cursor, use the arrow key, go all the way up near to the intersection point. This is the first curve, so we click yes. And the second curve, yes, we guess it. Now we got all the intersection points right there. I'm going to show you the second method of finding real roots by graphing. It's a little bit different from what we just did, but to me this is a whole lot simpler method, so pay attention to this one. Let's have a quick recall of what we just did in the last video clip. We talked about solving the equation of two functions. So what we did is we entered these two functions in the calculator and try to use the intersect functions to find the real roots. In this method, you're going to use the zero function of your calculator instead of the intersect features to find the real roots of the equations. The equation that we are looking at was this one. All we need to do is just set this whole equation to equal to 0 by doing minus x plus 5. So minus x plus 5, and then you end up getting x cubed minus 4x squared minus x plus 5 equal to 0. We are actually doing the system as well here, but right now the difference is the first one, y equal to minus 4x squared minus x plus 5, and then the other one is y equal to 0. Alright, so y is equal to 0 is basically we're looking at x axis. So we are actually looking at the intersection between this polynomial function and the x-axis. That's why we're looking at all these zeros. The following clip gonna show you the details of how do we find all these zeros. So first, enter your polynomial functions into the calculator. Then graph it. As you can see, there are 3 zeros. So in order to find the zeros, we use shift and then cal. Now select 2, enter. Then you can see the blinking cursor. Move the cursor to the left of the first zeros. Then hit enter. They will ask you the right bound now. So move the cursor to the right of the 0 and hit enter. Then they will ask you to guess yes. Now they show you the first 0, which is negative 1.093. Now we're going to repeat the same procedures. Check the zeros. Now we move the cursor to the left of the zeros. Hit enter. Then they will ask you the right bound of the second zeros. So we move to the right and hit enter. They ask you guess, yes. Hit enter. Then they show you the second 0. Then we repeat the same procedure. Shift, cal, check 0 again, enter. Then we move the cursor to the left of the last 0. Hit enter, which is tell the calculator is left bound. Then they ask you the right bound. You move up to the right of the zeros. Hit enter, guess, yes, hit enter. Then you find the last 0, which is 3.93.